today our topic is control system. So today we will discuss the introduction of control system. So before discussing in depth of control system, we have to understand what is called control system. So control system. Definition of the control system. The control system is that means by which any quantity of our interest can be maintained to a desired value or a desired range. So control system is a technique by which a quantity of our interest, that is which quantity we are going to be controlled, that is our interest. So that quantity can be maintained to a desired value. That means what value we are desiring, expecting, that value will be controlled. So this technique is called control system. Sorry, this one will be system. Okay. Now we have to take some example of control system. First, the most accurate and precise control system in our earth, that is the human body. That means if we take the body temperature, so body temperature is maintained to a approximately a constant value, precise value near 98 degree Fahrenheit. Okay, and this temperature remains constant, although there is some change at the surrounding. That means this temperature is precisely controlled by the body itself. So that's why human body is an example of a precise control system. Not only that, if we take temperature, then if we take the blood pressure, all these parameters of the human body, that is the next one is heartbeat, or pulse, everything are being controlled in a particular precise range. Okay, there may be various types of disturbance. What is called disturbance? That means the same human body, when a human being is going to the Darjeeling is in a cold environment, but the body temperature is maintained to the fixed value. If it is in the desert, that is a hot environment, then also it is maintained to the 98 degree Fahrenheit. So these types of surrounding parameters will create the disturbance. But although despite of that disturbances, there will be no change of the body temperature. That's why it is called a very much accurate and precise control. Next example is speed control of DC motor. Okay. That means if we are intending to control the speed of a DC motor, so in that case we have to do something, we have to introduce something so that the speed of the DC motor can be maintained to a particular value. So this type of control is also an example of a control system. Suppose we are going to control the DC motor speed to 1000 RPM. So this 1000 RPM, this value is called desired value, or this also called set value or reference value. Okay. Next example is driving a car at a constant speed. This one is another example of control system. Okay. In this case, the driver is maintaining the speed to a particular constant speed. So suppose that speed is 50 kilometer per hour. So this one is the desired value. So there are enormous examples of control system, and nowadays everything in the earth is precisely controlled, and itself the earth is surrounding the sun. That speed is also very much accurate, you know. So that one is also a very much precise control. The earth is rotating around its own orbit to a particular speed. That is also a very much accurate control. So everything inside the earth, we can see there are various applications and various examples of control system. So without the control system, we cannot imagine anything nowadays. Everything there is a control. Now we have to study in depth one of the examples. Suppose we are taking the example that is the speed driving a car at a constant speed. How this is done? So if we draw a block diagram presentation in this case, then it will be more easy to understand. So first there will be a engine, and engine will drive a motor, and this motor will drive the wheel of the particular vehicle. So we call that this one is engine motor. So this motor is rotating with a particular speed. Now this engine motor is our process or the system. This is actually the system, or it also can be called process. That means process is whose parameter is going to be controlled or maintained a particular desired value. That system is our first target. So this one is the engine motor is our system. So if we take a particular system, so we know for a particular system there will be obviously an input, and corresponding to that input we have an output. So this one is the input and this one is the output. So in this case the output is the speed of the wheel. Output is speed. Input is rate of flow of wheel. Now this one is a system, so that means there are obviously a relationship between the output speed and the rate of the flow of the fuel. So if we increase the fuel rate, then speed will be increased, and if we decrease the fuel rate, then the speed will be decreased. So obviously every system should have a relationship between the output and input. Okay, so there also will be a same relationship between the speed and the fuel flow rate. Now we have to control the speed. That means we have to maintain the speed to a particular desired value. Suppose this value is 50, speed, rotating speed. Suppose this rotating speed, now suppose 100 RPM. Now the question will come, what will be the input if we are going to achieve this 100 RPM speed? That means there must be a particular input value. For that input value, we will get this 100 RPM speed. So who will determine that value? That means that value will be determined by the controller, or in our case, or more precisely we can say, this input value will be controlled by the actuator. So next one is the actuator. The actuator is, in this case, which one is the actuator? Now the actuator will be accelerator pattern. And who will drive this pedal? So the leg muscle of the driver. who will drive this muscle? Actually, our brain. Driver brain, and as well as we can say brain and eyes. Okay, done. Now the desired speed is also 100 rpm. Reference speed or desired speed. Reference speed is also 100 rpm. Now the question will come, how the driver will understand that is the actual speed is 100 now. This speed may vary. This may be 90 or 110, anything else. So how the driver can understand now the wheel is rotating with a speed of 100 rpm? That means there must be some sensing through which the driver can understand what is the current actual speed of the engine motor. Okay, so now this output is measured and displayed by the speedometer. And this, from this speedometer, the driver can see the speed, actual speed. Okay. So this one is a entire control loop for driving a car at a particular speed. Okay. So seeing the actual current speed, driver brain will calculate the how much pressure will be exerted on the pedal, and accordingly he will give the pressure through the leg muscle. Okay, and after getting the pressure from the leg, the actuator will be pressed. Okay, and depending upon the actuator, the rate of flow of the fuel is controlled. And if this fuel flow rate is controlled, then that flow rate will give us the actual current speed. So if the speed is decreased, then the driver will give the more pressure and it will generate more fuel flow and it will increase the speed. When the speed is reached to the 100 rpm, the driver will keep the pressure to be constant at that time. At which pressure the driver will feel now the speed is now reached to the 100 rpm, then driver will stop to increase the speed further, increase the pressure further. Okay, so by this technique, the driver actually controlling the speed of the vehicle. So this is a complete example of the control system. In this way, we can take several number of systems. I am not going to details of that system. Now we have to discuss what are the different types of the control system. Basically, there are two types of the control system. One is called open loop control. one is called closed loop control. Again, this closed loop control can be divided into two parts. One is called manual control and another is called automatic control. Yes, so this one is a closed loop control because in this case there is a feedback. Which one is the feedback? The sensor itself is giving the feedback. So there is a feedback path and this one is the forward path. So starting from the controller output to the process, this path is called forward path. And starting from the output of the process up to the controller, this path is called feedback path. And most of the cases we deal with the feedback. This feedback is a negative feedback. Most of the time we will consider the feedback as a negative feedback. Normally the positive feedback is not a common. So in this case we are also considering the negative feedback. So actually what is going on inside the brain of the driver, that means it will always comparing the actual speed which is coming from the feedback path with the desired value. So driver will compare these two speeds, okay, and produce a error term. So what is the error term? Error term is the difference between the reference speed and the actual speed. So what is the error? So error is reference value minus actual value. And if this error becomes 0, then driver will decide we have to make the pressure to be constant at that time. So error is to be 0. This is our desired case. That means when the actual value reaches to the desired value, then the error becomes 0. So obviously this system is a closed loop control system. So this one is a manual control. It is a closed loop control, but it is not the automatic control. It is a manual control because driver is obviously a human being. So the control is basically done by the driver, and that's why this driver in our block diagram it is called controller. Okay, and this pedal is called actuator. And this engine is called the process. Now we have to take an example of open loop control. What is this? So the normal open loop control, when we control the speed of our fan, ceiling fan, we have a knob. Through that knob we are controlling the speed. There are different point 1, 2, 3, 5, 3, 4, 5 like this, and if we select a particular point, then corresponding to that point we are getting a particular speed. But now the question is, this system is an open loop system. Why it is open loop system? Because what is the actual speed of the fan? It is not measured by any sensor. We cannot see what is the actual speed of the fan. Okay, we cannot see what is the actual speed of the fan inside the regulator. Okay, so that's why we will assume it. If we select the point 5, then we can assume the speed is maximum. But what is the speed? What is the actual speed? We don't know. Okay, so if we are desiring to control the speed using this type of system to a particular value, it will not be precise, because the fan speed depends on various types of parameters. Among them, one of the most important parameter is the voltage. So there may be some fluctuations of voltage. There will be a voltage drop. There may be a voltage increase. So suppose the 230 volt it becomes now 180 volt. This may happen. So in that case, the fan speed will be decreased. That is for the same point. That is point number 5. We will not get the speed which we may get when the voltage is 230 volt. That means we are getting the speed, reduced speed compared to the previous one. That is for 230 volt. So we cannot control the speed precisely in that case. So if we want to control the speed precisely, then we have to sense the speed. We have to measure the speed, but that is not provided inside our regulator, fan regulator. So that's why that option is not given to us. So this type of system is now the open loop system. The another example of the open loop system is, suppose we are going to control the temperature of a room. Okay, in the ancient period, this was done. That is, there is some manual open loop control. Okay, what is the system? If we say, suppose this one is our room. Whose temperature is to be controlled. Okay. Now, surrounding this room, there are pipe, and through that pipe, there will be some steam flow. So, around this room, there will be some pipeline, and through that pipeline, there will be some steam flow. Okay. So, in this case, if the room is a system now, and if we want to control the temperature of the room, then what will be the input? Can you say? Temperature is the output in this case, and input is in this case the steam flow rate. So steam flow rate is the input. If we increase the steam flow, then temperature will be increased. If we decrease the steam flow, then the temperature will be decreased. So obviously there is a relationship between the temperature and the steam flow rate. So obviously for this system, input is the steam flow rate. Now we have to control the steam flow rate so that we can maintain the room temperature to a particular value. Suppose that temperature we are going to control it at 25 degrees centigrade. Okay. Now, this steam is generated from a boiler. Okay. What is the boiler? There is a constant inlet flow of cold water. And the water inside the boiler is boiled by supplying the heat with the coal. So we have to provide or supply the coal. That is, the coal is burned, and after the burning of the coal, there will be some heat, and that heat will boil the water inside the boiler, and that boiled water will be coming out from the boiler in the form of steam. So the input of the boiler is the coal supply. Okay, and that coal is supplied by a skilled operator, skilled human operator. That means, depending upon the amount of the coal supply, the heat will be generated inside the boiler. So if we increase the coal supply, then the steam flow rate or the steam temperature will be increased. Okay, and if we decrease the coal supply, then steam flow rate will be decreased. Okay, so the coal supply is controlled by the skilled human operator. So now, how the human operator can understand how much coal is to be supplied now, so that the room temperature will be maintained at 25 degrees centigrade. There will be a chart. What is the chart? That means there will be a chart. Inside the chart there is a relationship between the room temperature and the ambient temperature. Okay, so there will be a chart. Chart denotes that if the ambient temperature is this much, then I have to supply this amount of coal for achieving this temperature. Okay, there will be a chart or graph. That means you can say this one. There will be a graph. This one corresponds to the 25 degrees centigrade room temperature. This one is the ambient temperature, and this one is the coal supply. So there will be like this several number of graphs. This one corresponds to 30 degree, this one 35 degree, then this one 20 degree centigrade, like this. Right? So if the human beings know the ambient temperature, for that ambient temperature he will get the coal supply. Okay, and accordingly he will supply the coal to maintain the temperature to a particular value. This system is now an open system, because in this case there is no feedback. Through that feedback, the skilled human operator cannot know what is the actual temperature of the room right now. he is delivering the coal depending upon the ambient temperature, but there is no information to give what is the actual temperature now. Either it is 25 degree or 30 degree, that is not clear to give. Okay, so he will take the action depending upon the temperature. So this temperature, ambient temperature, so ambient temperature is the input to give. Okay, so this type of system is the open loop control. What is the advantage of this system? That is, the system is very much simple. It is very much simple. There is no complication of extra controller, sensor part, that is not present at all. So the system is very much uh, simple, and it is very much low cost. Cost is not so high in this case. But the disadvantage is the system is not precise one, it is not accurate. Although the human being is supplied the accurate coal towards the boiler depending upon the ambient temperature, but there may be a permanent deviation, permanent fluctuation of the actual room temperature, because there is no information of actual temperature towards the human being. He is unable to know that. So that's why he is assuming the room temperature is 25 degrees, but it is not that. So that's why, due to the lack of information and lack of the feedback, this type of system will not give the accurate or precise value, and this may sometime generate a permanent loss to the system. Okay, when we are producing some product inside the industry, so if that type of system is used, then due to the lack of information, there may be some permanent damage. All the products are damaged, but the operator is unable to know that. He cannot know what is going on. Either the product is damaged or it is perfect. So this will give a huge financial loss for a industry. So in the ancient period, this type of system was developed, and due to this huge fault, they will face a huge financial loss. That is not acceptable. Not only that, sometimes as this system is required the continuous human intervention. That's why, due to the sluggishness or the lack of consciousness, there will be a huge loss. That means in this case, the skilled human operator must be careful all the time throughout the 24 hours. That is not possible at all for a human being. So that's why this system is too much faulty. So that's why nowadays this type of system is not developed at all. Nowadays all the systems are closed loop system. So for the closed loop system, this fault can be avoided. Now we will take the log diagram presentation of a control system. What is this? Before discussing that, In this subject, we will be confined to basically to the closed loop automatic control system. Okay, so our focus throughout this subject is closed loop automatic control. Now let's see the block diagram presentation of the closed loop automatic control system. So first we have the plan or process. The output of the process is this one, and this one is the input of the process. So this output of the process will be sensed by a sensor. In this case, we will call that sensor part as feedback element. So this feedback element will deliver the output to some electrical form, normal. Okay. So this value in the electrical form or the actual value of the process now will be compared by a comparator. So comparator should have two inputs. One is the desired input or the set point. It is called set point or reference value. And this one is the measured value, measured actual value. These two will be compared and the comparator will give the error term. This is the error. Now this error will be supplied to the controller. Controller will take that decision depending upon the error term, and that decision will drive the process to achieve the desired value. Okay, so this output of the process is called controlled variable, which variable is being controlled, that is called the controlled variable. And the after this there will be the actuator. So there will be another block. Just a minute. Just a minute. There will be actuator. And after the actuator, we have the process or plan. controller. So output of the actuator is drive the process. So this output is called manipulated variable. Okay, that means in our previous case, that is rate of flow of the fuel, that is our manipulated variable, and that rate of flow is being controlled by the actuator directly, and actuator is driven by the controller. So the decision of the controller, this one is called control action. Okay, so now variable means in this case we are dealing with the various types of process variable. What are they? That means variables means that is speed, temperature, level, pressure, flow, like this. So these are all the variables. That is which variable is going to be controlled or maintained at a desired value. That is called the control variable. That means in our previous case, driving the car, the speed is our control variable, and the manipulated variable is that process variable by which we are controlling the control variable. Okay, that means rate of flow of the fuel, that is the manipulated variable. If we do not change the flow, then we cannot change the control variable. So with the help of the manipulated variable, we can control or maintain the control variable to a desired value. So that is the manipulated variable. So manipulated variable in our case, it is the flow rate of fuel. Now we have to discuss what is called system. That is, system is an entity in which an input is given and a corresponding output can be achieved. That means if we consider the system by a block diagram, that means this one is a block, this block is now a system, and for the system we have an input and there is an output. So inside this system, we may not know what is inside the system. System is a black box. We do not know what is incorporated inside the system. Only the definition of the system is that one which will deliver a output corresponding to a input. That is the system. Okay. Now, if a system exists, there must be an output corresponding to the input, and there will be a relationship between the input and output. Okay? So there will be a relationship between the input and output. So obviously the output, if the output is yt and input is ut, then the output yt will be a function of ut. Okay, so in this case ut is called independent variable, and yt is called dependent variable. Okay. Now, next one is, in the control system, we basically deal with the dynamic system. So what is called dynamic? This one is a system. But next, we will be confined to the dynamic system for our discussion. That is, the control system basically deal with the dynamic system. So dynamic means, that means in this case, the input and the output will vary depending upon the time. Okay, that means input and output, both of them will be a function of time. That is called the dynamic system. So, in case of the dynamic system, time is the independent variable, and input and output, both of them are the dependent variable. Depending upon the time, the value of the input and output will be changed. Now, if we model the system, if we represent this system by some mathematical representation, this is called mathematical modeling. So if we model this dynamic system, then we have to mention the function, this function. So we have to determine this function. If we are going to model the system, we have to represent the system some mathematical equations or mathematical modeling. So if we can find out the expression of this f, that is the function, then we can model the system by our mathematics. So in case of the control system, our first intention is to model the system. That means, what is the significance of the control system? That means, if we have to control that particular system by some technique or by the control system, we have to know the relation between the output and input of the system. And that relation can be determined if we can find out the relation or this function. Okay, so control system first objective is to determine the relation between the input and output of a process, which process is to be controlled. Okay. Next one is, we have two types of system in our control. One is called SISO. One is called SISO. This is called, full form is single input, single output. Like this one. There is a single input UT and corresponding to the input there is a single output. This is called the SISO system. Next one is called MIMO system. Full form is multiple input, multiple output. If we see the MIMO system with a block diagram, then MIMO system will be this one. There will be several number of inputs like C1T, like R1T, R2T, R3T, Rn. There will be n number of inputs and suppose there will be p number of output. So output will be C1, T, C2T, CPT. That is p number of output and n number of inputs. Okay. Now, what will be the relationship in this case? This is the MIMO system. In this case, the function, this function will be a matrix form. That means, in this case, C1T will be a function of all these variables, input variables. R1T, R2T, up to RNP. Similarly, C2T will be a function of all these inputs. R1T, R2T, RNP like this. Suppose this function is F1, this function is F2, like this. This system is the MIMO system. But in our control system is BTech UG course, we mainly confine with the SISO system. Yes. So up to this point of discussion, what we will get, that means in our control system discussion for the UG course, we can understand we will be confined to the SISO dynamic system. Up to this. Next day we will discuss the linear system, non-linear system, time invariant system, time variant system, causal system and non-causal system. These three topics will be discussed on the next day.